You may recall that all horizontal lines have a slope of 0. And here's 4 horizontal lines. These lines are parallel. Here are the equations for these 4 lines. Here's 4 lines that all have a slope of 2. You'll notice that these lines are parallel. Here are the equations for these 4 lines. You can tell that they're in slope-intercept form. The slopes are all 2. They all have a different y-intercept. The third equation just says y equals 2x, but remember that that means 2x plus 0, so the y-intercept for the third equation is 0. And that brings us to this. Turns out parallel lines have the same slope. Or, another way to state it, if 2 lines have the same slope, the lines are parallel. Here's something else. These 2 lines happen to be perpendicular. And here are the equations for these 2 lines. The line that goes from lower left to upper right is the top equation, y equals 2x plus 2. It has a y-intercept of 2 and a slope of 2. The other equation for the other line, y equals negative 1/2 x plus 7. You can see the y-intercept is 7, and from that y-intercept, it goes down 1 and over to the right to get another point on that line. That point happens to be the point where the 2 lines intersect. It turns out that when lines are perpendicular, their slopes are opposites of the reciprocals of each other. So the first line had a slope of 2, the reciprocal of 2 is 1/2, and the opposite of 1/2 is negative 1/2. Here's another example. The 2 equations are y equals negative 3/2 x take away 3, and y equals 2/3 x take away 3. And you'll notice that negative 3/2 and 2/3 are the opposite of the reciprocals of one another. Also, you'll notice that in this case, both lines have a y-intercept of negative 3. Well, here's a possible problem you might see on a standardized test or a regular math test related to this topic. This problem won't take long. It simply says, write an equation of a line that is parallel to the line from the equation below. Well, there are infinite lines parallel to the line from the equation below. But all of these lines have to have a slope of 3. So here's a possible answer. It's y equals 3x plus 42. Here's another possible answer. Y equals 3x take away 4. They both have a slope of 3, but they each has a different y-intercept. And here's one more. This is the one with a y-intercept of 0. If you wanted, you could write an answer in standard form. But remember, in standard form, the slope is the opposite of a divided by b. And in this case, a is 3 and b is negative 1. So the opposite of 3 divided by negative 1 is 3. And that's what we want, a line with a slope of 3. And I don't know that this is what I would choose, but here's an answer that's in point-slope form. The important thing is the line that goes with this equation has a slope of 3, and that's what the instructions wanted. Most problems will be more specific because for grading purposes, it's easier if there aren't infinite right answers. So here's one that says, write an equation of a line that has a y-intercept of 5 and is parallel to the line from the equation below. Then write your equation in standard form. Well, the first thing we need to think about is if the lines are parallel, they'll have the same slope. So if the first equation has a slope of 3, then the second one will have a slope of 3. So we write that, and then we put 5 where b would be because it had to have a y-intercept of 5. So that's the answer in slope-intercept form, but there's one more piece to the instructions. Write the equation in standard form. So we're going to add negative 3x to both sides to get this, and that's standard form. But if you're in a situation where you prefer to have a to be a non-negative number, we're going to have to multiply both sides by negative 1. And here's another way to write it in standard form, probably the preferred way, the one at the bottom. 3x take away y equals negative 5. And here's a very specific problem, and this one's quite a bit more complicated than the first two. We need to graph an equation, y equals negative 2x minus 3. Then we're supposed to write and graph an equation that is perpendicular to the line from the first equation and passes through the point 35. And then we have to write our equation in slope-intercept form. Well, let's start at the beginning. Let's graph the first equation. Since it's in slope-intercept form, we're going to find the y-intercept and graph that first, -3. And then from the y-intercept, the slope is -2, so we're going to move 2 down and 1 to the right and plot a second point. Our 2 points are now shown. Of course, to graph the line, we connect those 2 points and extend them to show that the line goes on forever in both directions. Now we need to graph and write an equation for a line that passes through 3, 5. So we're going to graph 3, 5, and we have 1 point for that line. Now, since that line is perpendicular to the first line, it has a slope which is the opposite of the reciprocal of the first line. The first line slope was -2. The opposite of -2 is 2, and the reciprocal is 1/2. So from that point, we're going to go 1 up and 2 to the right for a slope of 1/2. Here's 2 points for our new line. We connect them. We've now graphed an equation, and we've graphed a line perpendicular to the line from the first equation, and our new line passes through 3, 5. And the one thing we need to do is to find the equation for the new line. Well, we know the slope is 1/2, but we don't know the y-intercept, so we examine. But in this case, the y-intercept is not an integer. So to get it exact, we're going to write what we know, which is y equals 1/2 x plus b. Then we're going to take a look at one of the points we already know, the 3 and the 5. We're going to substitute the 3 in for x and the 5 in for y. And then we're going to do the arithmetic and write it as a decimal because it's easier to type. We're going to add -1.5 to both sides and get the b as 3.5. And then we write our equation in slope-intercept form using decimals because they're easier to type, and we get our answer, y equals 0.5x plus 3.5 as the equation for the line which was perpendicular to the first line, and our second line passed through the point 3, 5. And just for fun, let's pretend that that problem wanted our final answer in standard form. So let's take a look at our equation in slope-intercept form and change it to standard form. Well, how about if we multiply both sides, because multiplying decimals by 10 is mental arithmetic, giving us 10y plus 5x equals 35. Then we'll add -5x to both sides, and we're close, but recall that most definitions of standard form want a, b, and c to be relatively prime, and many like the a to be non-negative, so we're going to take care of that with one more transformation. We'll divide both sides by -5. And when we do, then -5 over -5 is 1. So it'll be x minus 2y equals -7. And a is 1, b is -2, and c is -7. And our equation in red is the preferable way to write our equation in standard form. To summarize, parallel lines have the same slope, and perpendicular lines have slopes that are opposites of the reciprocals of each other.